Example 4 is taking us into some context here. So a golfer is at the driving range, one where you can be above ground. So he's 32 feet in the air. So that's why the y-intercept of the function that's given is 32. It says, when does the ball hit the ground? So the question is, well, what's the x value when the y value is 0, right? Because y in this case is going to be the elevation of the ball, and x is the time since it was hit. So we're going to set the ball or set the function equal to 0. And when you do that, you just solve for the function. The first thing is they take out a GCF of -16, and then they factor, and then you're getting that x can equal -1 or 2. So the zeros of the function are -1 and 2. In the context of this question, 2 is the only one that makes sense. It doesn't make sense to go back in time. The ball's not going backwards. We don't have a time machine. So 2 is the answer. So after 2 seconds, the ball will hit the ground. Similar type of question here. It's from a baseball stadium. Let's say someone on the other team hit a home run at a Phillies game, and then the person in the stands gets the ball and throws it back. Right? That happens a little too often, I guess, this last season. But so similar type of question. All right, so you're going to set the whole thing equal to 0 and then solve. So why don't you pause it, try it, and then come back for the answer. So I set the function equal to 0 because when the ball reaches the ground, the height of the ball will be 0, and we're solving for x, which will give us the time it took that value to equal 0. First thing I did was I factored a GCF of -16 out. Then I factored x squared minus 2x minus 8 into x minus 4 times x plus 2. The two zeros are 4 and -2, but the only one that actually makes sense is 4, meaning the ball will hit the ground in 4 seconds. That would be your answer there. All right. Let's take a look at the next example.